another question of geomatics engineering. The following observations were made to determine the sensitivity of two tubes. The distance of the staff from the instrument was 100 meter and the length of one division of both bubble tube is 2 mm. Okay, so here these are the readings. Okay, and we have to determine the sensitivity of both the tubes, tube A as well as tube B, and they have given the readings, LHS, RHS, both the readings they have given, as well as staff reading. So from staff reading we will get staff intercept. So let's start to solve this question. So how we will go about this question? So first of all we have to write down this data. So for bubble tube A, okay, for bubble tube A, now when the bubble is on the extreme left division, so we have to see the LHS. Okay, so first case is for bubble tube A when the bubble is at the extreme left division. Okay, so the bubble reading on LHS, let me denote it by L1. So L1 is 13, and at the same time bubble reading on RHS. See, here I am seeing only bubble tube A. Okay, so bubble reading on RHS, it will be small r1, that is 5, and here staff intercept or staff reading. First let's find out, write staff reading, that is S1, it is 1.681. Okay, same way when the bubble is at the extreme right division, so corresponding value will be bubble reading on LHS will be bubble reading on LHS. Here I am writing L2, so L2 will be equal to 8. Just look at this table. Okay, then bubble reading on RHS, it will be denoted by small r2, so its value is given as 12, and staff reading it is S2, it is 1.767. okay, so total number of divisions. Okay, so total number of divisions for which bubble is moved. So here total number of divisions for which bubble is moved So here the formula is small n is equal to L1 minus R1 minus L2 minus R2 divided by 2. We know the values of L1 R1, L2, R2. Okay, you can see from here the all these values L1, R1, L2, R2 I have written here. So same values we have to substitute in this formula. So it is 13 minus 5 minus 8 minus 12 divided by 2. So it will be 6. Okay, and here staff intercept S will be S1 minus S2. So you can see what is S1 and what is S2. 1.767 minus 1.681. Okay, so 1.767 minus 1.681. So here the value of S you will get 0.086 meter. Okay, now we have to find out the sensitivity of the bubble tube. So the sensitivity of the bubble tube the formula is alpha is equal to S upon ND into 206265. This you have to memorize. It is in seconds. So S is staff intercept, that is 0.086. The value of N we have just found out, it is N is equal to 6. Okay, N is equal to 6 multiply by D 100 meter. Okay, so distance we know and it is given in the question, and this is 206265. So basically the answer is 29.56 seconds. Okay, so this is the answer for sensitivity of the bubble tube. Which bubble tube? I am writing down bubble tube A. Okay, same way we have to do the procedure for bubble tube B. Okay, so I am writing similarly. I hope you can do it yourself. So similarly for bubble tube B, just you have to put the values. First you have to find the value of N. So it will be again L1 minus R1 minus L2 minus R2 by 2. Same formula. I am just directly writing the values. Okay, you can look at this table. So 15 minus 3 and 6 minus 14. Okay, so 15 minus 3 minus 6 minus 14 divided by 2. So here you will get answer equal to 10. Same way staff intercept S. So staff intercept will be S1 minus S2. So here it will be 1.788 minus 1.635. Okay, 1.788 minus 1.635. So how much you will get? You will get 0.153 meter. Okay, so now directly apply this above formula. So alpha is equal to S upon ND. I am not writing the whole formula. Directly I am writing 0.153 divided by 10. N is 10, D is 100 meter into 206265 seconds. So alpha is equal to 31.56 seconds. Okay, so this is for tube B. Okay, thank you very much.